Hi guys, just a little update on what's happening with USB-C, and you will find now that more and more devices come with USB-C sockets on them, and there are chargers and hubs that have USB-C ports on them. And you might have noticed by now that not all hubs, chargers, cables are actually compatible, even though they might have a USB-C type plug on one end. USB-C is kind of becoming ubiquitous. It's going to be used for everything, even for having HDMI over USB-C for monitors and all sorts of stuff. So therefore, just because you see a socket on a device that has a USB-C output doesn't necessarily mean that you know what it is. And also, if you use the wrong cable, you will also not get the right response. So let's talk about that a little bit. So I find that I had to go through all of my cable supply with this little cable tester here to see really what they are and put them in separate little bins so that I can use them when appropriate. Some are charging cables and some are data cables. Doesn't mean that the data cable can't charge, but some of the charging cables do not have any data pins, so they definitely cannot be used in order to transfer data from like a hard drive or another computer or a device. Now you can see it is marked as 10 gigabit rather, transfer rate. And indeed, when you plug that in the cable tester, you will find that this particular cable is actually a USB 3 based cable. It has the one set of TX and RX. If I put the plug in the other way, it actually goes to TX1, and that is one of the first standards. Just using D plus and D minus would go up to 480 megabits per second, if I remember correctly. But when you have TX1 and TX2 and RX1 and RX2, you can actually go up to 10 megabits per second. I think there was a standard for 5 megabits as well, but in any case, that's not what we are discussing today. We are showing that there are different cables with different capabilities. So this particular cable, it does have ground and V-bus, but it might only be good for maybe 1 amp at 5 volts or something like that. And you will notice that the CC1 line and the CC2 line are not connected. So that means that using this cable, the power delivery, which is a standard now on USB-C sockets, would not work. And all you're going to get is 5 volts. So as I said, that's important to know about a cable. If you've got a high-speed SSD or something like that, this cable would be no good because it is an older one that only has 10 gigabits per second. Now here is an older USB-C to USB-C cable that I've had for quite a while. Let's see, to USB-C to USB-C. And when you plug that in, you will find that it is really a USB 2 type cable. Has none of the extended RX and TX pins connected. So this is a low speed cable and does have ground and V-bus. It does have CC1 and CC2 connected, so this cable would work on a PD controlled port. It could negotiate a higher voltage than 5 volts. Then you have This is like, it says Blitzwolf. This is like a charge cable. It actually has a little port on there. And from that we can see also that it is a low speed cable, but it does have charging capabilities, and if you look carefully you'll see it says 100 watts. So this is and normally if you're charging, the display will show the current and so on that it is consuming. So this is basically a charge only cable. You wouldn't want to use this thing for data transfer. But then you have newer cables, and this is one of them. I got several. This particular one is actually marked USB 4, 240 watts, 40 gigabits, 8K at 60 Hertz. So this cable purports to be suitable for everything: charging, high data rate. And when you plug that in, you will find that all the pins are connected. Now the D1, D minus and D plus pins, they will go from one side to the other depending if you turn the plug around. You'll see that the other ones are now lit up. That's normal for those particular pins. So that is what we have, and that's what you got to be aware of. And there are some cables over here that things like this tend to come with cheap devices, and they will include a little cable. And as you can see, this one doesn't have any data pins connected at all. It only has V-bus and ground, which means this is a simple charge cable for 5 volts, and it doesn't do anything else. Cannot transfer any data at all either. And it always gets stuck. Okay, so therefore I mark this thing charge only so that I know what I am dealing with here, and that I don't accidentally pick it up and plug it in one of my little devices that needs to transfer data. All right, so I'm going to switch cameras. So as I said, the first hurdle is the cables, and you got to make sure that you have the right cables, otherwise you might not get any proper charging or no data transfer. So you got to know what you're doing with those. And it's not always clear when you purchase those what those cables are capable of. You really have to test them sometimes with one of those testers. Okay, so this here is a power supply that I've had for a while, and it has a number of type A ports on there. This one uses is capable of the Qualcomm 3 protocol, which we won't discuss here, but it allows some cell phones to charge quicker and so on. These are standard A-type sockets, and you'll see that they all default to 5.5 volts really. And that's why when you use a cable that has a type A socket on it and a type C on the other end, charging will always work, because these particular type A ports are meant to have 5 volts on them always. But when it comes to these type C ports, they tend to have power delivery protocol, PD. This one is a 65 watt. I got another one over there that's 100 watts. And in fact, some of the newer ones, I think Ugreen now has a 240 watt one. So they have protocols to actually negotiate the different voltages, like 5 volts, 9 volts, 15 volts, 20 volts, 28 volts, 48 volts, and all of those around 5 amps. So as you can see, it actually defaults to 0 volts. It's waiting for you to plug something in there that negotiates the right voltage. Okay, so when you buy devices nowadays, they all now tend to come with USB-C ports, and thank goodness for that, because I hated those micro ports. And you can see there's the port here, and right next to it here is a little black hole, but there's a little light behind it, so you know when it's charging. So in any case, if I plug this in like so, and I plug it into this device, you will see that absolutely nothing happens. It stays at 0 volts, it's not charging. However, there are some devices that actually do charge. For instance, I have this screwdriver over here, and it comes with a USB-C port on the back of it, as you can see. And when I plug that in, even with the simple cable here, that's just for charging, you see it immediately goes to 5.2 volts, and you can see the little light is on, so it is actually charging. So some devices that are more advanced will have either a little chip in it. So the way to get these power delivery USB-C type devices to chargers to work, and that includes, you know, when you have these little wall-wart type chargers that have a USB-C port on the back of it. I think Apple is providing those for their devices now, and some of the mini computers and so on, they only have these USB-C ports on the back of them, and it's getting more and more ubiquitous. They're using USB-C ports for everything, but it doesn't mean you don't know the capability of it, what it actually is. In any case, when you have a device like this is a USB PD trigger, and it has the little chip on there that actually communicates over the CC1, CC2 lines and so on to negotiate a voltage. And if I plug this thing in, it goes to the last voltage that I selected. It says 9 volts. I push the red button here. Next one is 12 volts, 15 volts, 20 volts. Goes back to 5, then 9, 12, 25. That's all this thing is capable of. This is an older, this is a PD 65 watts. As I said, I have a 100 watt one over there, which would potentially have some other voltages. Nowadays, you can get charges up to 240 watts, but they're far and few between. I think Ugreen has one for $100 or $200 or something. It's quite expensive. That can actually go right up to 48 volts, I guess, at 5 amps. In any case, that is one way that this power delivery port will behave when you put a device in there that is capable of communicating with it. Another way, a simpler way, is to have a 5.1k ohm resistor pulling down from the CC1 line, and you will find that there are these little plugs over here. This is a USB-C plug that actually is meant to be soldered onto a cable. Has some solder pads on there. Comes with some little housings, which actually I've used one over here that kind of looks like that. And they have such a resistor on there. If we look at it under the microscope, you'll see. So as you can see over here, there is a resistor over there. We hold it down so it doesn't move. And that resistor is connected to like CC1. and there's a little capacitor there. I think that's across V-bus and ground, probably just to filter out some glitches or something. In any case, so this little plug will when I plug it in, will actually tell the power supply to go to 5.2 volts. There are others you have to be aware of. They do not have the right CC1 resistor on it. This particular one here has a resistor, but it's a 65K resistor, and it's across V-bus and ground. So I made up a little adapter over here with one of those little plugs on that side, and I put a little female socket on the other side. So now I can actually plug that in, and as you can see, it immediately goes to 5.2 volts. And now if I plug in my little device, you will find it will charge quite nicely with this little adapter. You can see the little red light is on and it is charging. However, if you don't feel like creating a little adapter like that, there are things you can get. First of all, one option is if you only have USB-C ports and you need to charge something that doesn't support the PD or doesn't have a 5.1k ohm resistor in it, you can use these little adapters. These is USB-C to type A, and when you plug one of these things in, you can see immediately it goes to 5.2 volts, and now that behaves like a standard USB-A port, and you can just plug in a charge cable that is like this, and that works. So that's one option. Secondly, there are certain hubs, and this is I've got a little hub here that has a adapter here for USB-A, or you can plug it into USB-C, and it is a cheap hub. This one over here, it has a USB-C output. There's a type A output here and 3 more there, so there's 4 of them. It's got an audio output and it's got an SD card slot. But this is a simple hub, and it does not have on the USB-C port, it does not have power delivery modes. But when you plug it in to the power delivery socket over here, you'll see immediately it went to 5.2 volts. And if I now plug in my cable into here, and again my little device over here is plugged in and it will charge okay. However, because all it is doing is offering you actually a USB 2 type C port, of course the data throughput would not be high, and also it'd be limited to 5.2 volts. Because if I now plug in my little device over here with the PD trigger, plug that in, and you can see in the background here, now if I hit the little button, nothing happens. It stays at 5.2 volts. But if you have one of those, you could certainly plug it into the USB type C port, and you would be able to charge and use either from the type A or even the type C socket. There are, however, more advanced little hubs, and this one over here has the high data throughput. It says USB 3, and I think it's like 10 up to 10 gigabits per second or something. And there's a USB-C socket there, and it is marked PD, as you can see. So it has power delivery mode, and in fact it even has a HDMI output on the other end here for an additional monitor. So when I plug that in, it does go to 5.2 volts, because that's what it needs to feed its type A sockets. And of course you can just plug in cables to the type A sockets and charge your little devices. However, the little PD socket on here is now behaving the same way that this one did. And I put in the little PD trigger over here. And now if I push the button, you see it will actually ask for the voltage from the supply there. So this one now is behaving the same way that this one did without the hub. So it's just an extension here, and this is the PD output now. Okay, so therefore you need to know what kind of hub you got and what the capabilities are. Alright, so I think that's all I got. Just some workarounds for those things. You may have noticed that some of your little devices won't charge from when you use USB-C to USB-C cable, because they tend to have power delivery on those ports. And what you can do is use an adapter or a hub of some description. If your device doesn't have type A ports to charge from, of course this one would be ideal, because you can plug it into your USB-C ports and you'll have 4 type A ports that you can use. And I think that's all I've got for now. So if you thought that was useful, don't forget to like and subscribe and all that kind of stuff. And then I will see you guys later.